Okay, so before the break, we were looking at the basic idea of manipulating 3D modeling, the 3D stuff, models, and move the vertexes and edges and faces around till we get the shape we want. There was one other tool I meant to mention that I kind of skimmed right past. It was near the beginning of my notes, and I jumped over it. And it's kind of a nice one to work with, but we just move our vertices and faces, and maybe the edges around till we get the shape we want. Under this icon, we can set the color and other properties about the material, how it reflects light and stuff like that. How the shadows fall on it, all of that stuff. But it takes a little while to get used to it, some time-consuming things. Another tool that can be very useful, I'm gonna go ahead and delete this one. That was just random shapes. And my plan here is to kind of go over these tools real quick. Then we'll look at the data, how 3D data is handled. And then we'll go over an example of making something. That way that's fresh on your mind when we go to lab time, because this is definitely one you're going to want to play around with and make stuff to kind of get used to it. Start putting models together. It does take practice. And I have had lots and lots and lots and lots of practice. My first experience with anything 3D, I've always been fascinated by computer graphics. All the way back to when I started using computers in the 1980s, long before any of y'all were born. My very, very first experience with computer graphics was before the computer could handle things like shaded in faces. So it was just the edges and stuff like that. So I started messing with it that long ago and started doing 3D modeling. The first couple 3D models were in the 1990s. It took forever. Computers were a whole lot slower back then. So it took a long, long time. You'd go to extrude and then go get a cup of coffee while you waited for the computer to catch up to that with that extrusion you just asked for. And it was a very, very long process back then. And we definitely didn't have tools like this other one back then. So I've had a lot of experience with this. Also, one of my degrees is engineering technologies, which included an extensive assortment of computer-aided design classes. So I've also had formal training in this sort of stuff. If it looks, when we get to lab time, you think I made it look too easy. I'm trying to describe the steps in detail, and it takes it does take quite a bit of practice to get used to it. So, but it's fun. It's like art, doing stuff in 3D, drawing in 3D, or sculpting. And that's the other tool I wanted to look at. So if I add an object, I'll do a sphere this time. You can see the sphere kind of has a lot of things on it. So again, the orange square has our transform. I'll just move that back to the origin to kind of keep it a nice central location to work with. It has a bunch of faces to try to look like a smooth thing. So go in edit mode. You see there's lots of vertices and faces. And for this other tool, I'm going to add even more. So I'll with everything selected. And if it's not selected, you push A for selecting all. You don't need any extra keys with it, like in other software. That's such a common thing. It's just the A. Right click and subdivide that. Oh, there's already a lot there, so maybe 2. So now there's lots of vertexes. We could define very precise shapes with lots of vertexes like that. And so object mode kind of works with the whole thing at once. In edit mode, we can go in and work with each individual vertex, edge, or face. And sculpt mode is like that thing I just mentioned, modeling stuff with clay. So we have different types of chisels here. Draw things, sharp edges. Clay just kind of builds things up. Add some strips of clay, layer things, cut into them. Yeah, I'll start with this. So if I just start kind of, so now you see it's like forming little bulge spots. Oh, it's symmetry. If it tries to do it on more than one side, undo that. This thing up here in the top right, see there's X, Y, Z buttons. That is the mirror options. A lot of things are symmetric, so we often work with that. And then, like say for a character, we can do just the right half of the character and then mirror all that stuff to the left half and just work with the symmetry of the way living things are symmetric, so we can work with that. We can build up little bulges of clay here and like pile up some clay or cut into things. Oh wait, I go to crease and kind of carve little notches in there. Maybe I should pile some clay up there. I'm gonna pile a bunch of clay up here so there's enough to work with. Then I'll go to maybe the crease tool and carve some little indents into that. So it's just like sculpting with chisels is what it's supposed to be like. You want to have lots of vertices whenever you go to do that stuff. Come through here and back and forth, turn up the strength. So there's strength and how big of an area it is. That's carving something a little bit bigger. Kind of carve some stuff out there. Can add strips of clay over here on the side. Build that up a little more and grab another one of the chisels and cut some creases in there. And try to build up a little face, sort of thing. Going quickly here. That's another one that people find fairly intuitive. It's just like working with chisels, but it does take a little bit of adjustment getting used to, especially if you have the nice little art tablets with the really good pens. Then it is a whole lot like working with chisels. It takes some getting used to with the mouse. You can see it's like molding the clay instead of moving each vertex around in particular. So that gives another nice tool for creating this 3D data, this 3D model, which it's on a computer, so it's actually 3D data. So next thing I wanted to look at was how that data is stored. So in object mode to deal with the whole thing at once, edit mode, and you can control the faces and vertices all at once, or sculpt mode is kind of like modeling with clay. And all of them, it takes a little bit of practice to get used to it, so we're gonna have plenty of time for that. But I wanted to talk about the data. So that's the file I sent out a little while ago. Did y'all see the files from and an announcement on AviLearn? Well, they're there, so you can look at them. I guess they're going to show on my screen right now. So, like I said, it was saying 2D image vector graphics are nice stored in a markup language, because markup languages are sort of the ideal mix of human readability and formatted nicely for a CPU. But they get very, very cluttered with 3D graphics, all the other stuff we have to put in. So how we handle that is something like this. So this is a wave front file. A .obj is the extension on it. And this is what how our data is handled. This is the standard. So the most popular software for just building, if you're going to build a game engine, the things that are ready for 3D graphics to work with there's a library called OpenGL, just those letters. So OpenGL, and there's a subset of it called WebGL, which is improved for transmission, set up to work mostly with JavaScript. We can do web things in different languages, but the WebGL is kind of adjusted to fit optimized transmission speeds. But the libraries are basically the same working with them. It's just, are we transmitting it across the network, or are we planning on running it on a local machine? And most of our languages can handle those. It's almost standard. So if you wanted to work in, say, do a 3D game in Pygame, you would use a .obj file and pull out your 3D data this way. So you'd export it as its own file, and this is kind of what the data looks like. Which from Blender, to get this, I just went File, Export, the wavefront is the standard to work with for OpenGL graphics, and it's a good example of how 3D graphics data is handled. Up here at the top, a couple things about it. Then we get to this line. Our first one is on line 5. So vertex 1 is at line 5, or to remember that. So I guess from whatever line number we're on, we're subtracting 4 to get to our ordinal number, the first, second, third, we'll want those. So there's a V marking this vertex. And then we have one for each one of our vertices. Just each one, sequential text file. You'll have probably encountered that. It shows up in the SDEV 120 class and the SDEV 140 class. Just the basic way of storing data. Every data point gets its own line in a text file for a sequential data file. So kind of set like that, and we're starting some of them off with a V to say they're vertex data. And this one that I exported here has lots of vertices in it. So scroll way, way down past all these vertexes. Oh, and then we get to V in data. There it is. Starting at line 1960. So if we subtract 4 from 1959, there's 1,955 vertexes in this model that this is the data for. Then we get to V in, and this is our normal vector. A normal is like the perpendicular line coming out of something. So we have all those faces. We'll see the faces in a second. But each face is a flat surface. So there is a perpendicular line that points straight out of every single one of those faces in our model. And that's called the normal vector. It also, with 3D stuff, it helps to define outside and inside as separate from each other. What is outside the shape and what is inside the shape. So which way do those lines point to come out of every one of our faces? So that's what these are. These are normal vectors saying basically which direction is that face pointing in. As we scroll down, there's a lot of faces. So there's a lot of normal vectors for all that face data. But again, sequential text file, so everything just gets its own line. And then after that, you'll notice there's, and the next letter is F for faces. So if we have all of the vertexes, then we don't need both faces and edges. We can work with one or the other. Most people tend towards the faces and then the edges fill in around it. But in a similar vein, we could work with our edge data and then the faces just fill in inside of all our edges. So it's one or the other on them, and then all of our vertexes, all of our normals, and then we get to our face data. And the face data is spelled out like this. So we have 859 and a blank spot. That would refer to an edge. And then a 1 for the normal. So that first normal vector, our first face here uses vertexes number 859, 831, 3, and 78. And I guess we need to add 4 so to find them. So like the first one's 863. So we go up here, add 4 to that 859, find line 863. Somewhere around here, there it is. And so it's this vertex is one of the ones on that face. And that first face had normal vector 1, which was down here around 2000 somewhere. There it is. So here's our first normal vector. So that first face included that vertex, this normal vector, and a couple other on that list. You see there's a lot of data involved in it. Then also this vertex, and the 78th one in our list, which is all that stuff up there. Then the next face has our 385th vertex. We didn't define any edges here. And we use normal vector number 2 to define what is perpendicularly outward from the flat surface of that face, which we can also smooth off that and make that a rounded surface. And at that point, the normal vectors become even more important, because there's lots of straight outward from a round surface, and it looks a lot better on the computer screen. Does that storage of data make sense? And there's just lots and lots and lots of faces. We say what all the vertexes involved with it. If necessary, the edges, but generally most people seem to tend towards the faces. So when we just export a wavefront, a .obj file, the edge data is omitted and it gets filled in as needed, basically just surrounding all our faces. And then what is normal for that face? What is straight outward from the face? So that's how 3D graphics are handled. And if you wanted to do 3D graphics in, say, Pygame, you would export a bunch of these files to represent your models, and then you would just load these in to represent that model, and you might need to manipulate it at times and adjust those vertex lines and things. So it's not hard to work with, but it is kind of time consuming, because we have to load in all this data and work with that. So a lot of steps to it. Oh, don't save that. I apparently changed some. Oh, wait, one other thing in there. And along with that data, also had this. So if I scroll down, I think it was around line 4000 or so. Oh, too far. After the normal, it says use MTL. So use the material, and in this case, I just called it skin, and that file is also available here. So there's a human MTL, which is the material. I'll open that up. Then here is those things we looked at for the with the material, the metallic properties, the specular, the roughness. The thing is that this wasn't written by an American, so these abbreviations aren't in English. But from all I did was added a color, so I'm pretty sure that's RGB. That's the RGB data, red, green, blue. And then the other ones, to just see which one's which in case you ever need to work with it in programming, just make some extreme changes and see what changes in that sort of file, because those abbreviations aren't, they're not the English abbreviations. So one of the cases where Americans have to deal with what programmers in the rest of the world have to deal with, where everything uses the English terms and computer stuff. So, but you can just make quick, obvious changes, like turn the metallic up to 100% and the specular down to like 1%, and then see which one of those lines gives those numbers. Is probably a lot easier than remembering it. Then I added this Python script, which I'm going to go back to Blender to look at that So we delete this little sculpting face thing. I'll just select it, hit delete. The delete key works like normal, didn't mention that. And there's a lot of different things. So these different tabs are set up for specifically to be better for things. So like if we're using our sculpting tools, we really don't need to see the grid like we would for manually manipulating it. Actually, let me bring that back in. So we have those faces and stuff. And on UV editing, if I select this, you see it here. Maybe if I add a square, it'll be more obvious. Yeah, that'll work. It's going really, really slow. So this area here is for applying materials and coloring things in. And basically we'll see an unwrapped version of that. If I right click on it, oh, do I have to be in edit mode? Select it, go to edit mode. If I right click on it, oops, didn't mean to duplicate it. Okay, yeah. So it just kind of unwrapped it. And see how there's this surface here that, oh, that's a better view of it. There's these squares here. So it unwrapped it. So that's what each one of the faces on our thing looks like. I decided to bring in another cube because that was going to look like a mess with all the faces on that sculpted one. But then we have each face of our cube, so then we can save that as its own file, take that to some 2D drawing software, and if we had like, maybe we want that cube to be dice. So in the 2D drawing software, we can draw one face of the die here. So like white with one black dot, and then make this square white with two black dots, and white with three black dots, and so on, and we can see what goes in each face. So like on a character, we can have a 2D image, unwrap it, and then we'll see all the little edges for the creases in the face, and marks where the eyes and nose and mouth and ears and all that stuff are. And then in 2D software, we can fill in those details and then wrap that around our shapes. That's called UV editing. It's a little bit complicated, so not really a starting point, but that's how, just preview mode. Texture painting is to add the same thing with textures. So instead of colors, same thing with shading. We can define materials, and yeah, there's a bunch of things. So we can make things look like rusty metal with chunks missing, versus polished metal that's super reflective, and that gets a little complicated. Definitely not an intro thing, but I can point you towards some final versions on that. Rendering's the final version when everything's ready to bring it down. Composting, but all of our we have full control over these. This little icon here is which window we're looking at. So from anywhere, we can set it up the way we like it. And on a lot of windows, when we click one of the options, we'll get more options. They're not actually options, they lead to menus with more options. There's a lot of stuff there. So for starting out, probably just go with the tabs, like the layout, or sculpting, or the scripting. This is a programming course. Well, we just looked at the data file, how this stuff's stored in 3D data in a wavefront file, which is .obj extension. You might also want to do it in a Python file. So I did that here. That's what that other one in there was. Those files I sent out. Oh, that's for this evening's class. This one. This script here called addHuman.py. Instead of adding a cube and modifying that, I keep a human starting point around handy. So there's a bunch of stuff here, and I simplified this from the normal one. I had a bunch of comments in there. Y'all can look through the comments, kind of see what's going on with them. But basically, it's the same thing. So here's all our, oh, Blender's got behind on me. I guess I should wait for it to catch up. There we go. I think. When I click on something, the cursor went somewhere. So hopefully it's catching up there. There we go. What is it doing? Did I leave anything big going there in the other ones? Yeah, Blender seems to have froze up on me. I'm thinking it might be quicker to close this and open a new one. Because clicking through those other menus, I might have accidentally left something big going on in the background. Which does that, some of the things Blender can do will slow down a computer a lot. I was trying to avoid some of those things today, but in the UV editing window, and the render window, or the shading window, there's some really big things in there. So I'll just open Blender back up because I apparently left something running in the background, slowing everything down. Open a general one. So there's our basic shape, our starting point as a cube, a camera, and a light. We hit W to get to the selection tool I like, and then just select all those and get rid of the default ones. And now back to where we were. Over in the scripting tab, which I can tell my mouse is moving quicker now, so that's something. If I open one of those files I sent you, was addHuman.py. Okay, yeah, and it seems to be going at a much better speed now. So there's some libraries we need. BPY is the library that has all of the Blender functionality in it. So basically, that's the Blender software that the user interface sits on top of, so that we can get to all the objects, the classes, and methods built into the software. MathUtils is one of the libraries in our in the basic language. It comes with a regular install of Python, and it includes a specific vector object. So brought that in because we have all of our vertex data as vectors. So y'all might remember the syntax for a list, which is square brackets. So we have a list of things, a collection of things, a whole bunch of vertexes all at once. And vertexes are a point in space. So in this case, three-dimensional point in space. We go over 0.18, I guess. Then in the negative y direction, negative 0.02, so almost right at 0. And then in the positive z direction, 1.47. And we come to that point, and instead of a point, which is a locked position in space, we treat it as a vector. So that instead of that single point, we kind of think about it as the arrow going from the origin to that point. Because an arrow is a lot bigger than just a point in space. We can move that arrow around and think about what it's doing, which direction it's pointing on. So our vector graphics, the points are treated as vectors. So we have a whole bunch of those in the list. And then we have a whole bunch of faces. And you'll notice each element in that list of faces is a list itself. And just like we saw in the OBJ file, that's the vertexes it's referring to. And in this case, for working in Python, that's our index of this other list. So it's going to use the vertexes verts index 912, the verts list or array, if you prefer that terminology, index 884. Then 2, oh, that's one we can kind of see here. There's 2, if I scroll over, it's going to use this vertex here. So we'll use all of, so those are the indices of which vertexes to use to define this face. And then the edges, just let those blank because they're obviously implied from all our faces. So grab that data, and there's a lot of them here. So I come up here and go to WordWrap, or WordWrap on. You see it's this is the same one as that other file. So we saw there where there was line numbers, there's 2,000 vertexes there. And then several thousand faces. So lots and lots of data representing the 3D model. Turn off WordWrap. So I'm going to take that data, and this command creates a new mesh. So I left this here for copy and paste things in case y'all want to mess around with that in Python. And we're going to create that mesh from some Python data that includes the verts array, the edges array, and the faces array. So it'll put all that together to make a new mesh. And then we're going to make this new object. So the Blender library has a thing called data in it, has a thing called objects in it. We're going to make a new one that we'll call human. We do need both of them because internally it's going to be stored as dictionaries. Some of y'all may not have seen dictionaries yet, but that's a keyword value pair. Dictionaries are a really nice data structure because the short version of it, things like arrays and lists and stacks and queues, those are stuck to our program. But a dictionary can leave our software and work with another piece of software. JSON is probably the most popular type of dictionary data, but it uses just regular strings and includes the name and the data in one thing so that we can send it somewhere else and it has the name and the data in other software, other languages and everything. So, so we have to have the same name twice basically. So we're going to create a new thing from this mesh and we'll call it a human. And then it's a good idea to work with collections, just an organization thing. That's kind of over here in this window where I was clicking on things where all the names are. For the short starting out point, think of a collection as a folder. So you organize your stuff. So you have a collection of the scene stuff as your cameras and your lighting and the backgrounds. And then you have a collection of your main character and the mesh or skin and the armature or skeleton for that, the main character, and then sort of a different folder for all your stuff to keep it organized. So these last couple lines create a collection and then put that new object into the collection. So if I run this script, we get that new object added in there. So that's basically what the add buttons do. Which is a point I mentioned earlier. It's a human, but only drew half the human. And that's because of symmetry. Living things are symmetric. So for the big details, the exact shape of this character's ears, horns, how big his hands or feet are, the big details we can work on just one side and duplicate them to the other side. So if I select that, let me get where it kind of fills the screen a little bit better here. And another one of our menus here, I guess looks like a wrench. It's called Modifiers. If you hover over it for long enough for the text, so the modifier one's very useful because that's the built-in things that one of the ones on the menu, which the thumbnails are in my way here. Those, and then come back over here. One of them is mirror. Where is mirror? There it is. We can just mirror that and then just automatically duplicate that half we have to the other half and get a full starting point for a human character. And then we can come in and do a bunch of editing and stuff. So like maybe we want this character to have horns. It's some sort of demon-like character or something. So we can come in here and like we saw, maybe select a few of these faces and then use that extrude tool. So extrude that out, something like that. And with that surface selected, we can hit scale to bring it down a little, rotate Y, kind of curve it upward, and extrude another one, which bring that upward a little more, scale it down so it's like coming to a point. Yeah, and notice when we do something on that side, it automatically duplicates to the other side. That was the first thing that sprung to my mind for a quick example. But then, yeah, like armor for the character or the exact size, all the sizes and the details. We only have to work on one side. And then when we're done, well, we can see it in edit mode. When we go in edit mode, we only have half the character to work with. But even though we see it while this modifier is here, eventually we want to come back to object mode and hit apply. And now it is a single object. Notice that modifier with all the controls disappeared. And if I go in edit mode, we now have all the things to work on for the fine details. Okay, so things like a scar on the character's left cheek doesn't need mirror. So those final details, we apply the modifier and do that afterwards. So it's a very useful tool, and I sent that out so you can use that as your for a starting point for characters. Let me undo that. Oh yeah. So after you get all your details on one side done, again, Control Z is undo. And you apply your modifier to make it one thing. And another button you might want is there's an awful lot of flat surfaces there, right? So under Object, there is an option for shading smooth. And then kind of round off all the edges. But again, then it's just a matter of adjusting those vertexes to the particular shape you want for the character. 259. Anybody have any questions about that? Okay. So I'm going to delete that thing with the horns. So it only took a couple seconds to add horns to that character. So if you wanted to make like a Viking thing, you'd probably grab a couple faces, stretch it out, scale it out a little, and then grab a couple faces and extrude it out for the horns on the Viking helmet. Quick, easy change, and so that makes a good starting point. And that file, I send it out so you have that to start with. That way you're not starting completely from scratch. and just kind of get used to some of those adjustments by applying details, or take it over to the sculpting thing and use those chisel tools to sculpt things. And you have the file there, so you can start over. So when things don't go, it's a trial and error. Yeah, try some stuff. If it gets too messed up, then go download the file from IvyLearn again and start over without starting completely from scratch, which I'm going to do on this next one. So add cube, and then I'm coming back over to the scripting tab. If it wasn't obvious, I did not type that data in. I did not sit there and type in 2,000 points. So I'm going to close this script, link, and I'll make a new one, which because of the example I sent out, I'm going to call it script name.py. So you probably want something a little bit better than script name.py. And all of our Python scripts, we're going to start by importing the BPY library. And in those files that I sent out, there's also this, well, the name says what it is, convert Blender mesh to Python script. So these are the instructions that we put into our Python terminal to do this. So copy and paste these. So here's the 4 instructions to grab all that stuff. And in the terminal, we'll do them one at a time. So I'll just use Shift and the N key to select that first one, Control C to copy. And then that note is make sure the object you want is selected. So select that object. And under the scripting tab, you can just paste this into the terminal. So ran that. We don't see a result because all we did is grab that data and store it in a variable. Now we need to write that variable, what's in that variable, to our file. Whoops, this one has a file. And that's this next line here. So again, Shift and hit the N key to copy it, or whatever method you would normally use to select to copy a line of text. So we'll copy that and paste that in here. It matters where your mouse is. My mouse was down here in this other window, so Control V didn't work. I put it down here and put Control V, it's not pasting anything. If I bring my mouse up here to the Python interpreter window and hit Control V, then it pastes. So that's how it knows to paste there instead of in the text file. Now when I run that second line, you see it wrote that line with all of the vector stuff. And it just does it right where the cursor's at. So I'll give that a name. So verts is that array now. So the end, add a little bit more lines. So this time I'll put the name first. Say faces equals, and then get those last 2 lines from that text file. So that's that as well. That's something you can just copy and paste these lines. They use list comprehension to grab all of those things. Oops. I made a video about list comprehension that is in the supplemental video section on IvyLearn if you want to see what the list comprehension is. So basically, instead of typing all those values in, we just create the list as needed. Tell the computer how to find the data that we want in our list. So this isn't actually a list of things. This is instructions for how to find the data we want to put in this list. And that's called a list comprehension. It's not really a introduction level thing. So I made a short video talking about it, but here it's a copy and paste thing, so you can see what it does. I guess you can see that instead of typing a bunch of elements in the list, we put a for loop in the list, a for loop and a condition in the list, so that the computer can just go find it. And then an instruction to write that text file, write that to a text file at the current location of the cursor, and there's all our face tag. So I turn on word wrap. So that's what a cube looks like. You can see there's 1, 2, 3, 4, 5, 6, 7, 8 vectors. So the 8 corners and 1, 2, 3, 4, 5, 6 elements in the face data, so the 6 faces. So that's the data defining a cube, which you might want to work with in your programming sometime, right? If you're going to write your engine, or some engines are still completely library based and we have to do the text thing. We saw that in Pygame. A lot of our popular game engines that have been around for a while, they attached all of that coding library stuff in the background to a user interface, so we just click the buttons, which is much, much easier to work with. Did anybody get a chance to play with Game Maker over the weekend and see how much easier it is to work with than Pygame? It's a very intuitive thing. I assume the silence means no. Everybody was busy, had a busy weekend or something. Some weekends are busy. I felt like I was going nonstop. Oh, messing around in Inkscape is good too. The 2D vector graphics, and because vector graphics are nice, we don't end up with that issue that's traditionally the reason artists tend towards MacBooks, which, well, we're talking about graphics before this last little thing. Let me describe that issue, since this is a learning environment. Has everybody encountered that before? Like artists always want to use MacBooks, and sometimes you might draw stuff on a PC and you open it on a different computer and it looks a little fuzzy. The reason for that is our pixels are all lined up in a grid, right? They have this big grid of pixels. And when we talk about pixel data, we're always dealing with integers, but those are actually real numbers. They're floating point things. And on a Linux and Mac system, it internally gets rounded. So this is raster graphics. This is that pixel by pixel data. It internally gets rounded. So we might have something like this over here, over here, over here. And it brings that data in. And then this little wavy line, let me put that closer to the middle. And then that little wavy line of where the actual pixel information is, Windows and Linux will round that to the whole number value of the grid. It works, it looks straight, gives us a line. Pixels are very, very close together, so usually anymore we don't notice it quite so much. Mac, on the other hand, so that's PC and Linux do that. Mac, on the other hand, with raster graphics, the pixel by pixel data, Mac rounds first. So if you draw a straight line in Mac, the operating system rounds it and then stores those values. So by the time it gets stored, it really is a straight line. Because obviously, if this is what our data looks like, another computer, we open that picture on another computer, it might start doing something that's like, okay, these round to this point. Oh, well, this point rounds to this line. And then we're back to this line. So this sort of thing where it stores the data and then rounds it, PC and Linux, can get as little jagged edges. Whereas a Mac, it rounds it first and then stores a straight line. So a straight line drawn on a Mac really is a straight line. Because if we open this on any other machine, the data is stored there. A trade-off for that is it takes more processing power. And as a result, because of that, Mac computers have to have more processing power. They have to be more powerful machines because of how they do the graphics. But then that carries over elsewhere, and that they're typically more powerful machines of comparable Windows or Linux machines because of that right there. But that's raster graphics. That's storing all of that pixel by pixel data. If instead we use vector graphics, and instead of saying all these points representing pixels, we just store an equation of how to recreate the image we want, then we don't end up with that wavy line issue. So the vector graphics bypass that as well. So obviously, like we saw when you export an image, export a bunch of animation frames, you're probably going to want to do those into pings. Pings or GIFs. JPEGs can't handle transparency. We'll go to a ping data, so we do usually turn it into 2-dimensional. We do usually turn SVG graphics into raster graphics at the final step before we use it. And pixel densities kind of reached a point that it's not an issue like it used to be, but it does still exist, and vector graphics gives us a way to bypass the issue all around. Because then we're calculating it at runtime, not ahead of time on a different machine. Just thought I'd mention that. But this stuff does take a little bit of playing around with to get used to. So I'm gonna do a quick thing to kind of go through the steps of forming an object instead of randomly using the tools. And that way it's fresh on your mind when we go to lab time in about 10, 15 minutes here very, very shortly. And then this is definitely my recommendation to start playing around with this stuff. I'm gonna start with a cube and turn that into something. I got the cube here. I don't want a cube, so I'm gonna go in edit mode and adjust all these faces and vertices. And first off, I'm gonna add a bunch more of them. So I'll right click and subdivide that to get some more edges. And on the little menu down here, number of cuts, maybe 7 cuts will work. Yeah, 7 will work nicely. You get a bunch of little spots to work with. But a starting point, the fine details take a little while. Now I'm going to come up to this button and use face selection instead of vertex selection, which is just a matter of preference, because if we select all the vertexes around the face, I'll do that before I switch it. That also selects a face. But we could alternatively just go to face selection and select a few. So I'll start by I could probably make this a little longer. So I'm looking at a cube, like the artist thing. Like, I think I can turn this into like a dragon really quick in a couple minutes, or the start of a dragon. Obviously not a final Hollywood CGI quality, but get the basic shape of a dragon. So maybe make this a little bit longer in the y-axis. I'll put his head going the negative y direction. Oh, the green axis is y, the red is x, and the blue is z. That's not written down as an official standard, but that's pretty much what all software has gone to. That way it's consistent when we go between different ones. Green is x, red is x, green is y, and blue is z. You see it matches x, y, z matches our normal RGB order. So to make that the body of a dragon, probably need to make it a little bit longer. I'm gonna hit S to scale it, and now I only want to scale in the y direction, just make it a little bit longer, and just drag it out. And when I do that, I like to have like the move thing here as a reference point to grab. Even though I hit S to turn on the scale feature, it was I was using that arrow as a reference on how far to click and drag. I find that useful. Okay, that'll work for a start. And then go in edit mode. Probably need a head to the dragon. So I'll grab some little spots here. Oh, have the box select. So I'll hit W to get to the selection tool I like. And then maybe grab some of these from the middle. That'll work. And then I'll hit E to extrude and just bring that out a little for like the neck. So bring it out, maybe move it up like that. That'll probably work. Then I'll extrude it out again. Extrude that, kind of straight out like that. I'll grab these ones down here at the bottom, or grab them one at a time. Hold Shift and select these faces at the bottom, and hit E to extrude, drag that out. Maybe S to scale it down a little. First now, something like that. And that's the process. We just grab things and make little adjustments till we get to the shape we want. We'll finish out the head. Probably need some sort of ear here. It looks like I don't have enough vertices. Excuse me. So I'll hit the K for the knife tool and cut a couple more edges in here. Somewhere around there probably work. Enter. Whoops. Undo that and try that again without that last little error. So there's a lot of undo and redo. I was kind of come across there and make some more faces to work with, so that I can now grab one of those faces, or maybe two. And even though they're separate from each other, I can still hit extrude and bring them up. Scale them in the X direction. Something like that, kind of get some start on the shape going. I guess the dragon needs a tail, so I'll come back here and oops, try to select some faces to, once again, extrude out and make the tail of the dragon. And that's probably something that's going to be wavy whenever you go and animate it, which is the skeleton structure like we saw. So I want to put a lot of extra edges in there, and that way it gives a bunch of pinpoints. So I'll come out a little bit and hit scale, make it smaller, and maybe move it up a little. Then extrude another one, hit S, scale it down a little, and move it up a little. Extrude, S, E to extrude, S to scale, and then move it to an approximate position. E to extrude, S to scale it down, and then move it to wherever it needs to be. Something like that. That'll probably work. You can come over here and grab some spots to make a leg. So maybe these 4 will work, or however many that is. So E to extrude, and the leg needs to point downward, not straight outward. So this time I'll put R to rotate, and then Y so that it's restricted that it can only rotate around the Y axis. And bend it down a little. E to extrude. Once again, rotate restricted to the Y axis, so RY, and get something more downward. E extrudes that. E extrude it one more time for a small bit. And I can change all these faces here. Grab these faces on the front and extrude that out for what would eventually be claws on a dragon or whatever animal this is. I'll come back here, grab a number of faces to kind of do the same thing for a back leg. Extrude it out a little, rotate R for rotate, Y for the axis, and kind of bend it down so that after a couple, E for extrusions and rotate Y, that it's eventually pointing straight downward. And again, it takes some undoing and redoing and all of that stuff. To eventually animate it, I'll leave a couple seams as it comes down. A small one here at the bottom, where you can grab the front feet and extrude that out for what would eventually be like claws on a dragon. And I guess those four will probably work. And maybe two back here as well. So a dragon needs wings. So again, select the faces, E to extrude, then maybe kind of bring it outward, and R on the Y axis, and rotate that till it's, the faces are pointing the directions, because extrude always goes straight outward. And maybe S to scale on the Z axis and make it narrower. That'll work. So now E to extrude, and here I'll S to scale on the Y axis, make a wider part, and then move that back. What I was thinking is that the front of the wing will be roughly straight. Those faces are still selected. I haven't deselected them yet. So E, extrude the next section, scale Y, and I'll bring that in a little, move it up to kind of keep that front edge straight. E to extrude the next section, scale Y, make it nice and big, bring it back like that. E to extrude, I'll do scale Y and make it a little smaller. Something like that. Kind of gets us a starting point, right? Roughly looks like a dragon. I guess the next thing is to do it on the other side. And this is a point I already mentioned, that living things are symmetric. So I'm going to switch to the wireframe view here. And with the lasso select, I'm going to try to look straight on and select just half of it. I switched to wireframe view because with wireframe, we can select through the one we're looking at. With when we see the faces, we can't click through them. But with wireframe, I was able to click through them and get all the way back. That wasn't quite half, but I guess it'll make a wider dragon. That'll be fine. The general steps are hopefully there. So I'm going to delete that entire half of the dragon. When we hit the delete key, we choose what to delete, either the vertices, edges, or faces. If we deleted faces or edges, we would end up with a gap. So usually we want to delete the vertexes because everything else is based off the vertex. The edges just fill in between vertices. Think of it like a connect the dot picture, so that if we want to delete stuff, we really need to delete the dots, not the lines connecting the dots. So that kind of, if I switch back to material, little views up here, that kind of looks like half a dragon, or the start to half a dragon. So come back to object mode, and on the little blue wrench looking thing, the modifiers, I can add in a mirror modifier. I get the thumbnails on my way. There we go. And kind of fill in the other half and get the starting point for a dragon. And that's the general process. Does that make sense? So you choose a face, extrude it out, kind of put it in the position you want. And I remember Control Z is undo. So there's lots of undo and try again along the way until you get roughly the shape you want. And probably want to leave it with just the mirror modifier and then just work on that one half to get the details worked in. Like that cube, that should probably be rounded off and things and do all that. And under this button, I think it's supposed to be a colored in, like a colored in ball, but it looks to me like the more like the radioactive icon than anything else. We can add a new material that is roughly green in color. So just under base color, oh, is not responding for some reason. Did it catch up? Oh, there we go. Pick sort of a dark greenish color to apply. So if we look at it in material mode, now the dragon's kind of green. And a very useful one is object shade smooth. Oh, sorry. Select the object and then the shade smooth button. So a quick pass, probably not the best dragon. And then that text file I sent out with those instructions for the scripting tab, what goes in here, we just do that and get a starting point for a dragon object on those. I guess I'll send this file out after class. That would be another good starting point because you can still go in there, go to edit mode, and mess around with the vertexes and faces and everything to kind of make that look a little bit better. Often when editing though, it's probably better to do the edit mode with the shade, with the flat shading, and then the smooth shading is the final version. So I think I will send this file out. What's over here? Oh, the data for a cube. We don't need to keep that. Oh, I guess if you use these lines, notice I just called that script name.py. That does need to be whatever you name your script. So create a new one and then save it and all of that. And probably change that line before copying and pasting, unless you just want to call it script name.py. And then animation is the same as 2D, only quicker and a little bit easier. And we also have a very powerful thing that I'm only going to mention. But I think I'm going to push that back to the start of Wednesday because then we're going to talk about Game Maker, which is very easy and most people find very easy and intuitive to use. So our talking about that will go very, very quickly. So I'm going to push it back to animations, and maybe we'll just use this thing to animate the dragon. So I better go ahead and save it. I'll save that. Where's the delete folder? In the delete folder, oh, the zoom buttons are in the way again. I'm not a big fan of disappearing buttons. I find it frustrating more often than it's helpful. Dragon start. And then, well, for lab time, maybe you can finish that. Or bring in that human one and finish that and mess around with those to get some practice getting started with 3D modeling. Save Blender file. And just make little adjustments, but it does take a bit of practice to learn. So I want to make sure we get that practice. We have an hour and 20 minutes left on our scheduled time here today. So as always, I will be sitting here till 4:50, at which point I have to head up to campus for my 6 o'clock class. I hope the bridge is open yet. Anybody know if the bridge is back open? It takes a long time to get to from Clarksville to Sellersburg with that, when all the traffic backs up on one road. But I'll see what that's like. But I'll be sitting here till 4:50. If you have any questions, I would definitely recommend playing around with that. And then we will animate maybe that dragon thing that started with dragon just through and see the steps are still the same, and talk about a very powerful tool that always on software has a fancy name, but it's called inverse kinematics. I'll go ahead and talk about it since I mentioned it. It's like the old marionette puppets where we had the strings. If you think about it, when you walk, the only thing you're actually thinking about when you walk, if you pay attention, is you're only thinking about your ankle. Every step is just where to put the ankle. So if instead of moving every bone individually, we did like we think about it, and this is what the marionette puppeteers hundreds of years ago realized, all we have to do is control the ankle, and everything else in the leg comes along with the ankle. So we can also do that with our computer animations. It's a little complicated, so I'll probably just talk about it a little, or maybe that'll be all I talk about. I mentioned that when you hear that big fancy word, inverse kinematics, that's the old marionette puppets, where we would have like 5 or 6 strings to make all those puppets do all kinds of stuff. We can do that in software too. They just use the big technical sounding proper physics terminology for it. So it sounds like something fancy, but it's the old style puppets. Does anybody have any questions about stuff from today?
I don't think so, no.
Okay, I was about a half a second left on the waiting, but so I will be right here as always. Ivy Learn messages and text messages make noise on my phone. I'll be sitting here till 4:50 if you have any questions. Play around with that in lab time. See, and it does take some practice, so try to get some practice and working with those 3D graphics. Otherwise, I will see you all on Wednesday. The career coaching, one of the career coaches from that department is going to come in and say hi and talk to y'all for about 10 or 15 minutes on Wednesday. Then we'll get into video game stuff. So I will see you all then. Have a good one.
Are you too, Chris?
Same to you, Chris.
Have a good one.
Bye.
Also, I tried to